Let me start recording this session. And let's see, we're just going to do 30 minutes today, right?
Yep.
The way this works is I can write on this. You can see that okay?
Mm-hmm. Yep, I can sure see it.
Okay. Now, the only thing we have to do is get the problems that you want to work on to my computer. And you can either verbalize them, and I can write them out, or you can take a quick snapshot of a page of review material or something and send it to email. If it's not graphics stuff, then you could probably you can probably verbalize everything.
Yeah, I think I can. I wrote down problems that I can verbalize. So is that okay with you if I just do that?
For sure.
Okay. Do you want me to, can I give you the first problem?
Sure.
Okay, so I just got it from my review online. So it says factor.
Okay.
And then it's 2x squared minus 21x minus 11.
Okay, what goes here and there?
So you have to pull out an x and then another x, or a 2x and then an x?
Yes. That's the only possibility right there.
Okay, yeah.
Okay. Now what's the next step in factoring this?
Okay, so then you do what multiplies to be negative 11 and adds to be negative 21.
No, you can't use those rules anymore because we have different coefficients.
Okay.
If this was x and x, then you could use those rules. But the next step is to examine the sign there.
Okay.
And what that means is that it has to be opposite signs.
Okay.
But we don't know if it's plus minus or minus plus because it might make a difference because of the different coefficients there.
Okay.
Well, the easy part is that there's not very many factors of 11. So it's either 11 and 1 or 1 and 11 or 11 and 1 down there. So we'll check each one at a time.
Okay.
Does this work? And the way you tell if it works, we don't need to check the first. We're good. We know this term is correct.
Yes.
We know this term is correct. So the only thing we really need to check for is this middle term.
Okay.
And we do that by doing what I call my smiley faces. That's 11x there. That's minus 2x. That would add to 9x. So that clearly doesn't work.
Nope.
So now we try the next combination, which I would say, without giving it any thought at all, I'm going to put the 1 here and the 11 over there.
Okay.
Now, does that work?
Yes.
It does. We found our answer.
Okay.
So that's it. Had that not worked, then I would have tried both numbers with this second combination.
Okay.
Okay. So that's pretty much it's a lot of trial and error is what it is.
Okay.
Okay.
So you just kind of plug in to see what works.
Yeah, exactly. And like I said, the term that you want to make sure comes out correct is that middle term.
Okay.
By the time you get to that spot, you've already determined that the first term is going to work and the last term is going to work.
Okay.
So if this is all equal to 0, I know they said just factor it, and you've done that. But what would the solutions be if this was equal to 0?
So wouldn't it be, hold on. Would it be negative 1/2 and then 11?
Yes.
Okay.
Okay.
So if it asks that, that's just all I do is plug it.
Exactly. In other words, once you factored it and you set it equal to 0, then we know that either this has to be 0 or this has to be 0.
Okay.
And you just solve for both of those.
Okay, that makes sense.
Okay.
All right, so my next problem, it's factor the difference of two squares.
Okay.
And it's 9x squared minus 25.
Okay. The key equation you want to remember, and this is
Okay.
really important because you can't imagine how often you're going to get this question. The difference, it's usually called the difference of perfect squares.
Yeah, I think that's...
And what it factors into is this. If you have a squared minus b squared, it factors into a minus b times a plus b.
Okay.
Well, what is a? If I assume this is the difference of squares, then a must be the square root of 9x squared. What is that?
Okay. Isn't that just 3x?
Okay, and b must be the square root of 25.
So 5.
So how does this factor?
So do you just do 3x minus 5 and 3x plus 5?
You got it.
Oh, okay. I thought it, I don't know why I thought it was harder than...
Yeah, no.
Okay.
That's what's involved. The key is determining what is A and what is B.
Okay.
Now, notice that it really doesn't have to be the difference of perfect squares. If I had x squared minus 7, that's going to factor into x minus square root of 7 times x plus square root of 7.
Okay, so it works for others.
It works for everything. It doesn't. It's really a misnomer calling it the difference of perfect squares. Makes it easier to understand when you're younger, but it's not as robust as it actually is.
Okay, that makes sense.
Okay.
All right, so the next one is, it just says solve or perform the indicated operation. So it's 4 plus 1 over x, and then it's all over 1 minus 1 over x.
Like that?
Yep.
Okay. What do we need to do here? Well, we need to make the numerator a single term, a single rational function, and we need to make the same thing with the denominator.
Okay.
So how do we add 4 plus 1 over x?
So you have to get a common denominator.
Okay. Which is?
Wouldn't it just be 4x?
Would be x.
Oh, it would just be x because it's basically 4 over
that's
1.
basically 4 over 1, exactly.
Okay.
Common denominator is always going to be their product.
Okay.
Won't always be the least common denominator, but when you have a variable, that's all you have. So, and in fact, let's do this so that we have that's over x plus that's over x. There's the 1 over x. What's this going to be?
4 over?
4x over x.
4x.
Remember, it has to equal 4.
Okay.
In other words, the way I got this was to multiply 4 over 1 times x over x. You can always multiply a fraction by 1 without changing its value. And the secret to algebra is figuring out what that 1 should be. Okay. So 4x over x is the same as 4, and now I have a least common denominator. Let's do the same thing with the bottom. What does 1 become?
1x.
Okay, now let's simplify. Let's reduce the top. What does it become?
5x over x.
Actually, 4x plus 1. In other words, all you do is add numerators. And there's no x right there.
So you can't combine.
No, you can't.
Okay.
Like apples and oranges.
Okay.
Okay. However, since you have the same denominator, you can just add the numerators, which is what I did.
Okay.
And then the same thing in the bottom.
So it would be 1x minus 1.
Yeah.
Okay.
So now we have to convert that.
Okay.
Well, it turns out that if both denominators are the same, like they are, you can just cancel them out. In other words, the way we divide by a fraction is to flip this and multiply.
Okay.
Right? So this would be the same as multiplying this times x over x minus 1, which ends up giving you 4x plus 1 over x minus 1. In other words, as long as my denominators are the same, I can just cross them out.
Okay.
If my numerators were the same, I could not do that.
Okay.
It's only if the both denominators are the same that you can cross them out. If the numerators are the same, you got to flip it before you cross them out. So this is the solution.
Okay. And you would just leave it like that because you can't simplify it any further?
Yes, I cannot simplify that at all.
Okay. All right, that makes sense. Okay, so the next one, it says find the solution, and then it's the absolute value of 2x minus 1, and then on the outside, plus 4 equals 4.
Okay. First of all, tell me what this means.
Doesn't it just mean...
No, I made up this new problem.
Oh.
Tell me what that means. How are we going to solve a simple one like this?
So don't you just, when it's the absolute value, do you take is it the opposite sign?
Well, the first thing you do is remove the absolute value.
Okay.
So I would say x minus 1 equals 5. Then I put an or, and I do nothing different with what's inside the absolute value. Never change that. What you change is the sign on this other side.
On the other side, okay.
So if I was going to solve this problem, I would solve this, which is x equals 6, and I would solve this, which is x equals minus 4. So you get two solutions when you have a relatively simple one, okay?
Okay.
So now let's apply that logic to our problem.
Okay.
But first of all, we got to isolate the absolute value.
So you have to subtract the 4.
Yes. So now we have 2x minus 1 equals 0.
Okay.
So now what two statements can I say? I hate that this was the first problem they gave you.
Oh yeah. So you do 2x minus 1. Well, how would you do it since it's 0?
Well, 2x minus 1 equals 0, or 2x minus 1 equals negative 0, which is the thing. So in other words, you don't get two solutions here. You only get one.
Okay.
And x is equal to 1/2 or x is equal to 1/2.
Okay.
If you plug that back in, you see that that's true.
Okay.
Plug in x 1/2, you get 1 minus 1, which is 0, plus 4 equals 4.
Okay.
But the key is this step right there.
Okay.
And I write it horizontally because most of the time I have to solve it vertically. In other words, I'm going to have a more complicated problem normally, and I'm going to solve it in this direction. And I'm going to solve this one in this direction. Normally this is going to be a different number.
Okay.
And so that's why I put the or in the middle and write both possibilities horizontally.
Okay.
And that's the convention of how to do those also.
Okay. All right, so there's, I have another factor one.
Okay.
So it's 14x squared plus 3x minus 2 equals 0.
Okay, now we have more choices. Because 14, I could be 14 and 1, or I could be 7 and 2.
Yep.
What I recommend everybody try are the factors that are closest together first.
Okay.
That's just the way the Colorado school system makes their problems. This is kind of a trial and error thing. And so we want to maximize the possibility of getting it right with the fewest attempts.
Okay.
Okay? So what's the next step?
So then you have to, what was it? You have to find the, is it the multiple or something?
The next step is always to examine the sign on the constant. Now, I don't know why, most of my students have a hard time remembering that's the second step. But it definitely is, because that tells you about the signs. In other words, it's either plus minus or it's minus plus.
Okay.
And again, they're different because I have different coefficients. If I had the same coefficient, if this was 2x times 2x, I could just write plus, minus, and go from there.
Okay.
But since they're different. Now, the lucky part is that there's not very many factors of 2. There's 2 and 1. Let's start out and see if that works. Does that work?
No.
But it's close, right? In other words, it gives us a minus 3x instead of a plus 3x. So all I have to do is switch them to the down below. Yeah.
Okay.
2 and 1. And now it does work. That's minus 4x. That's plus 7x. That gives us 3x. So it's not totally trial and error. In other words, once you find something that's close, only off by the sign, then it's easy. You only have to try one more thing. You don't have to try all 4 possibilities.
Okay.
Okay, so we have factored it. We haven't solved it, but we factored it. They didn't ask you to solve it, right?
Yep.
Okay. They did not ask you to solve it?
No, yeah, they didn't ask me to solve it. It just says factor.
Okay.
But to solve like the other one, just plug in 0.
Well, you said each one equal to 0. In other words, 7x minus 2 equals 0, which means x equals 2/7, or 2x plus 1 equals 0, which means x equals minus 1/2.
Okay. All right. So the next one. Okay. So it's one of those 1-to-1 ratio problems. So it's f of x equals x cubed minus 8. And then it says is a 1-to-1. And then it says find an equation for f to the negative first times x. Okay.
Times x, like that?
Yeah, but so it has the f, and then it's like to the negative first power. And then,
find f inverse of x.
Yeah, the inverse.
That negative 1 right there is the inverse.
Yep. Okay.
Okay? All right, let's examine whether it's 1-to-1 or not.
Okay.
What is the parent function of this? In other words, you learned like 10 elementary functions. You learned y equal x, you learned y equal x squared, you learned y equal square root of x, you learned y equal x cubed, you learned y equal log x. You learned y equal e to the x, you learned y equal sine x. Those are all elementary functions. And if we know what each one of these looks like, then it's real easy to graph this. Because this function is merely one of these shifted down by 8.
Okay.
Well, it's this one right here. The reason it's shifted down by 8 is because this minus 8 comes completely after the function.
Okay.
Okay? So what does this function look like?
I'm not sure.
Looks just like that.
Okay.
In other words, the domain is all real numbers because x can be negative or positive.
Okay.
And the range is all real numbers because y can be from negative infinity to positive infinity.
Okay.
Okay? So if that is this, and this means it's vertically shifted down by 8, well, this key point right there, the inflection point, is now down here at minus 8.
Okay.
So I would draw something that I guess you would call it parallel. I don't know if it's really parallel or not. But it's this exact curve moved down without changing the shape. Moved down 8 units.
Okay.
Okay? So now let's examine whether it's one-to-one.
Okay.
For something to be one-to-one, I know I erased the proper curve, but doesn't affect its one-to-oneness. I can look at y equal x cubed. It has to pass the horizontal and the vertical test. In other words, something is only a function if it passes the vertical test.
Okay.
Something is a one-to-one function if it passes the vertical test, which this does, and it has to pass the horizontal test, which is, can I draw horizontal lines without passing through two different lines? And yes, I can.
Yes. Okay.
Okay? So this is one-to-one. Whereas something like this, which is a parabola, this is y equal x cubed, x squared, that is not one-to-one. It passes the vertical line test, but it fails the horizontal line test.
Okay.
Okay, so that's what one-to-one means.
Okay.
The other thing that one-to-one means is that I can create an inverse of it.
Okay.
In other words, if this is my function, I can find the inverse. The inverse is also a function.
Okay.
That's what one-to-one means. Now, how do we find the inverse? Well, first of all, let's make it look like this. Okay?
Okay.
Now, the process for finding the inverse is very simple. Switch variables and solve for y.
Okay.
2 steps. That's it.
Okay.
So when I switch variables, I get this. Now I'm solving for y. I get this.
And then you do the cubed root.
Then you do the cube root, and the cube root is the cube root of x plus 8. It's not plus or minus. It's just plus.
Okay.
Because when you're doing odd roots,
Uh-huh.
in other words, the cube root of 8 is 2, but the cube root of negative 8 is minus 2.
Okay, so...
It is not plus or minus 2.
Okay. So that's for...
Whereas if
odd.
I did, yeah, that's for odd functions. If I had this, then x is equal to plus or minus 2.
Okay.
Because that is an even root. But once you're doing odd roots, it's strictly the whatever sign you have.
Okay.
And that is the inverse function. I can rewrite it like this if I like. Maybe it's a little nicer. The cube root is the same as taking it to a 1/3 exponent.
Okay.
Okay?
So that's the inverse, that would be the answer?
Yeah, either this answer or y equal cube root of x plus 8. They're the same thing.
Okay.
That is the inverse function of what we
Okay.
started with.
Okay.
That. And there is a specific definition for inverse function, which I'm sure you've probably talked about. And that is that f of f inverse of x has to equal x.
Okay.
In other words, let me give you an example. If f of x is equal to x squared and g of x is equal to square root of x, well, is this the inverse of this? If it was, then f of g of x has to equal x. Well, what is f of g of x? That's f of square root of x. And that is, I'm going to substitute square root of x wherever I see x. So that would be square root of x squared, which is indeed equal to x.
Okay.
Okay? So that's really the definition of inverse.
The definition, okay.
Is the composite function, this is called a composite function, where f of g of x has to equal x and g of f of x also has to equal x. That is the definition that f and g are inverses of one another.
Okay.
So if we did that with that last problem, we would get x. In other words, if we took f of this function right here, we would get x. Because notice when we cube that, we get x plus 8. We subtract 8, we get x.
Okay. Do we have time for one more?
Yes. One short one. One short one. Unfortunately, I have 3 straight 30-minute sessions, so I don't have any leeway time here.
Okay, that's fine. So we'll just do a domain one. It just says find the domain, and then it's the square root of x minus 8. Okay.
When you're doing domain, there are not very many restrictions. There are those restrictions. There are this restriction, and there are these restrictions.
Okay.
That's about it. When you find that, you need to let x be greater than or equal to 0, or whatever's inside the parentheses.
Okay.
When you find this one, x cannot be equal to 0.
Okay.
And when you find this one, x has to be greater than or equal to 0.
Okay.
So for our problem, all I need to do is set x minus 8 greater than or equal to 0 and solve for it.
Okay.
So x greater than or equal to 8 is your domain.
That's the domain? Okay.
Well, now, do you use interval notation?
Yes.
Then let's write it in interval notation.
Okay.
What is that in interval notation?
So is this where you would use the union?
Well, we don't need a union because it is strictly from 8 to positive infinity.
Okay, so that's all you would do.
Now, notice I used a bracket, which means it can be equal to 8. If it could not be equal to 8, I would have used a parentheses. In other words, it's actually a little different problem if I make it this. Now notice that it can't even be equal to 8 because then I would be dividing by 0. So the domain of this problem would be almost the same, only it would be parentheses, 8 comma infinity.
Okay.
Because it would pick up an additional restriction that it would have to be greater than 0, not just equal, greater than, or equal to 0.
Okay.
And that is domain in a nutshell. Domain is actually very easy. It's really all about what x cannot be.
Okay.
Okay. All right. This work okay for you, the online, Madison?
Yeah, that was perfect. I'll definitely do it again for sure.
Okay, great. I've recorded this. The only thing I need is your email address to be able to send you the link for seeing this.
Okay.
Give me an email address.
Okay, so it's golden ME at S dot DCSD.
Can't understand those letters. S is correct?
Yep, S dot D C S. No, sorry, S.
S is in Sam?
Uh-huh.
Okay.
D K 12.org. Yep.
That's where it'll probably be tomorrow morning, but I will send
Okay.
you a email that shows you a link to review this session if you would like.
Okay.
I will always post it to that same link, and so you can always review the online sessions.
Okay, great. Thank you.
All right. I will talk to you next time. Have a good luck on your final, and
Oh, thank you.
have a good Christmas.
You too.
Bye-bye.
Bye.